Welcome, Swagatam. My name is melaghumakra Kumar, and today I am in the place of Mr. Chemistry Notankiwala. And next, I will talk about the next part of chemistry, and the related topic will be discussed by me. That is by Mr. melaghumakra Kumar. So, in the previous lecture, we learn about the total energy of electron, that is Mr. uh, Chemistry Notankiwala calculated the total energy of electron, and its value comes out to be En equals to minus ZE square by 8 pi epsilon naught R7. Now using the value, we get En equals to minus 1 by n square into mz square e to the power 4 by 8 epsilon naught square h square, and this value is constant and known, and putting the value of mz e epsilon naught and h, we get En equals to minus 13.6 by n square electron volt per atom, or En equals to minus 313.6 by n square kilocalorie per mole, and En equals to minus 21.76 into 10 to the power minus 12 by n square erg per atom, or En equals to minus 21.76 into 10 to the power minus 19 by n square joule per atom. In general, we use En equals to minus 13.66 by n square z square electron volt per atom. Here Z is used for hydrogen like atom. If we put the value of Z equals to 1, we get the total energy value for hydrogen atom, and if we put Z equal to 2, then it will give the total energy for helium, and so on. Now, negative value of energy implies that the electron is bound to the nucleus. As the value of n increases, and total energy En also increases, because En is directly proportional to minus 1 by n square, or inversely proportional to n square. Hence, the outer energy levels have greater energy than the inner orbits. Now, we can write En equals to minus z square by n square into E1, where E1 is the energy of first orbit, and given by E1 equals to minus 13.6 by 1 square equals to minus 13.6 electron volt per atom, because E1 value is for hydrogen atom, and here Z is equal to 1, and for first orbit n equals to 1. So, we have calculated E1 equals to minus 13.6 by 1 square equals to minus 13.6 electron volt per atom. Similarly, energy in second orbit for hydrogen like atom, E2 equals to minus 13.6 by 2 square equals to minus 13.40 electron volt per atom, and energy in the third orbit E3 equals to minus 13.6 by 3 square equals to minus 1.51 electron volt per atom. When n equals to infinity, infinity equals to 0, which is maximum energy. So, from it is clear that the difference between the two successive energy level decreases as n increases. Energy E1 is called ground state, and E2, E3, 4 are called excited state, and E infinity, that is E sub infinity, means that the electron becomes free from the nucleus. Now, here we see the energy levels for hydrogen like atom like He plus, Li plus 2, Be plus 3 ions like helium ion, lithium ion and beryllium ions. Here for a state, that is for if we choose n equals to 1 and z equals to 1, that is energy of first orbit will be minus 13.60 electron for atom. This is for a hydrogen atom, and if we choose n equals to 2, z equals to 1, that is energy of second orbit will be minus 3.40 electron volt. Similarly, for third orbit, minus 1.51 electron volt. For fourth orbit, minus 0.85 electron volt, and that so on, and for infinity it will be equals to 0. Similarly, for helium ion atom, for helium Z equals to 2, that is atomic number is 2. So, for first orbit N1 equals to 4 into minus 13.60 electron volt. For N2 equals to 4 into minus 3.40 electron volt. For N3 equal to 4 into minus 1.51 electron volt. 4 into minus 0.85 electron volt, dash, and so on, and for N equal to infinity 0. So, and so on, we can calculate for lithium ion and beryllium ion for both. You have to use only the Z value, change the Z value. Now we will see the velocity of electron in the nth orbit. So, from above equation, we have m Vn Rn equals to n into h beta 2 pi, or so Rn equals to n square into h square epsilon naught pi epsilon naught divided by pi into z into m into e square, or m into Vn into n square into h square epsilon naught by pi z me square equals to nh by 2 pi. So, we have Vn equals to 1 by n into Ze square by 2 epsilon naught h, or V1 equals to Z V1 by n, where Vn and V1 are the velocities of electron in the nth and the first orbit respectively. Now, first calculate the value of first orbit, velocity of first orbit using Z equals to 1 for h atom. And putting the value of E, epsilon naught and H, we get Vn equals to 2.19 into 10 to the power 6 by n meter per second. If we choose n equals to 1, that is for first orbit for hydrogen atom, V1 comes out to be 2.19 into 10 to the power 6 meter per second. Similarly, for second orbit, V2 comes out to be 1.095 into 10 to the power 6 meter per second, and V3 0.73 into 10 to the power 6 meter per second. The velocity of the electron in orbit is maximum when it is close to the nucleus, that is for n equals to 1, and as we goes to the outside the nucleus, the velocity decreases. Similarly, we can calculate the velocity for He atom only putting Z equals to 2, and for lithium atom putting Z equals to 3, and so on.